We are once again back with another webinar with the topic we have selected for this time, novel routing protocols for wireless sensor networks. As today's speaker is with us from Turkey, Professor Korhan Cengiz. He's senior member of IEEE. He was born in Turkey in 1986. He received his BS degree in Electronics and Communication Engineering from Kocaeli University, Turkey, and Business Administration from Anadolu University, Turkey in 2008 and 2009, respectively. He took his MS degree in Electronics and Communication Engineering from Namık Kemal University, Turkey in 2011, and the PhD degree in Electronic Engineering from Kadir Has University, Turkey in 2016. Since 2018, he has been an assistant professor, and since 2021, he's a department co-head in Electrical and Electronic Engineering department of the university. He's the author of over 40 articles, including IEEE Internet of Things Journal, IEEE Access, Expert System with Applications, Knowledge-Based Systems, ACM Transactions on Sensor Networks. He is owing 4 international patents, 4 book chapters, and 1 book in Turkish language. His research interests include wireless sensor network, wireless communication, statistical signal processing, indoor positioning system, power electronics, and 5G. He's handling editor of microprocessor and microsystem Elsevier, associate editor of IIT Electronics Letters, IIT Network, and editor of EEU, International Journal of Electronics and Communication, Elsevier. He has been guest editorial member in IEEE Internet of Things magazine and CMC Computers. He served several reviewing positions in different journals of IEEE and SMIEEE, Springer, and EMRA. He served several book editor positions in IEEE, Springer, Elsevier, Wiley, CRC Press. He has already done 20 plus keynotes talk in reputed IEEE and Springer conferences about WSN, IoT, and 5G areas. He's been awarded and honored by Tubik Priority Area for PhD scholarship, the Kadir Has University PhD Student Scholarship, the Best Presentation Award in ICAT 2016 conference, and Best Paper Award in ICAT 2018 conference. Covering his entire kind of caliber and expertise in a very short speech will not be possible. So without wasting much time, let us start our presentation. Professor, over to you now.
Thank you for your invitation again. Is it visible? Can you hear me?
Yes, we can. It is visible. It is audible, okay, and visible. Please proceed.
Okay, thank you. Thank you again for your kind invitation. Today, we will talk about routing protocols, the next generation solutions, and also maybe some Internet of Things based approaches for wireless sensor networks. Especially today, I want to present you 2 novel routing protocols which were designed by us, by me, and also by my PhD supervisor. Actually, we will talk about LEFCA protocol and also its extension, multi-hop LEFCA protocol. As a motivation, at the beginning, we will talk about the problems and also some recent studies about wireless sensor networks, and then in details we will talk about LEFCA and multi-hop LEFCA. Finally, we will see some simulation and evaluation results, and then also we will talk about conclusions and future studies about these topics. At the beginning, let us start with the application areas of wireless sensor networks. As we know, wireless sensor networks have been used in several areas, such as disaster relief, target tracking, environmental control, smart cities, medicine, and healthcare. Especially healthcare applications are promising nowadays due to COVID-19 and other health issues. So nowadays sensors are applied in different fields, and also there are some combinations between machine learning, deep learning, artificial intelligence, sensors, and also Internet of Things-based approaches. And in wireless sensor network, to distribute the sense data, in literature, there are several approaches, but especially 3 approaches are widely used: direct transmission, multi-hop routing, and clustering. In direct transmission, sensors measure the environment and then transmit the measurement to the remote base station individually. In multi-hop routing, some sensors are used as relay nodes, in other words, gateway nodes. And finally, in clustering, there is a cluster head which is responsible to collect measurements from the members and then transmit these packets to the remote base station. So our LEFCA protocol is a clustering protocol, and it uses clustering approach, and also it has a fixed clustering nature. I will also explain in details in the following slides. Our multi-hop LEFCA protocol is a combination of multi-hop routing and clustering. So we will discuss about it also. And as a related work, at the beginning, we should discuss about Leach Protocol. Leach Protocol is the fundamental and most known protocol for wireless sensor networks, and it has 2 main phases: setup phase and the steady state phase. In the setup phase, it aims to form the clusters, especially cluster selection, cluster advertisement, and also cluster formations by using a probabilistic function. In that function, sometimes maybe there is no cluster formation, and also there is no cluster heads. So it can be very dangerous, and it can cause to some serious problems, especially in healthcare applications and earthquake measurements. For some rounds, for some time periods, you cannot collect any information from the network. So it can cause serious health problems, critical problems. Therefore, especially for critical applications, healthcare applications, fixed clustering protocols can be better. In steady state phase of Leach, the collected measurements are transmitted to the remote base station, and then for the next round, these processes are done again. And in setup phase, again, it forms new clusters and also new cluster heads, and this can cause to additional network traffic and also additional energy consumptions. And also there are a lot of extensions to Leach. When you look at the literature, you can find thousands of protocols, thousands of approaches, algorithms, which are trying to improve the performance of Leach, especially in energy efficiency field. For example, LeachF is another extension to Leach protocol. It uses fixed clustering approach. Therefore, we made our comparisons with LeachF especially, and we tried to become better than LeachF in our analysis. Mode Leach also is another promising and also fundamental protocol for Leach-based ideas. DEEC also another fundamental protocol, and stable election protocol also another most known protocols in wireless sensor networks. So we made our comparisons with these protocols. We also analyzed them in details, and also we conducted their simulations in MATLAB platform. So here, let's start with the details of LEFCA protocol. Our LEFCA protocol aims to use fixed clustering and cluster head determination ideas together. And also it has an intelligent cluster determination mechanism, and it tries to determine the nodes that are almost at the center of their associated clusters at the beginning of the algorithm, instead of determining them randomly. In especially in general, at the beginning, the cluster heads and cluster formations are determined randomly in Leach-based protocols and also some novel protocols. But we also started to determine randomly in Lefka protocol. And then also we tried intelligent cluster determination at the beginning of the protocol. And we have obtained that approximately intelligent cluster determination provides 10% additional energy savings when it is compared with random determination at the beginning. So we then decided to use intelligent cluster determination. And also our Lefka protocol has a threshold-based cluster change mechanism. And in this threshold-based cluster change mechanism, we have a novelty. Our protocol aims to abuse the energies of the cluster heads before determining a new cluster head. And we have details, we looked into the literature and we found that this idea is not proposed in any of the existing algorithms. So this part is the novel part of Lefka protocol. And our Lefka protocol also has two phases, setup phase and the steady state phase. In the setup phase, first, we determine the clusters. In some protocols, at the beginning, the cluster heads are determined and then clusters formed. But in our protocol, first we determine the clusters because we have predefined cluster dimensions. For example, we have a network with the dimensions 100 meter to 100 meter in a square field. And then we say that we will use 8 intelligent clusters, 6 intelligent clusters, or 10 intelligent clusters. So, sorry, at the beginning, we define the network into equal pieces. And then for each piece, each part, we are trying to find the most suitable cluster head, approximately almost at the center of each partition. And then our setup phase completed. In the steady state phase, our cluster heads are responsible to collect measurement from the members and then transmit these measurements to the remote base station. So in cluster formation stage, in the setup phase, we have two main messages in the wireless propagation channel. These messages are advertisement messages and also the join request messages. In advertisement messages, cluster heads say that I'm a cluster head and you can join me as a cluster member. And then other sensor nodes join to the associated cluster heads by using this advertisement message, and also they broadcast join request messages to the associated cluster heads. And finally, cluster formation completed. And then once the cluster formation completed, each cluster head is responsible to broadcast a TDMA frame, time division multiple access frame, to the cluster members. For example, in a cluster, we have 10 members and 1 cluster head. So we need 11 time slots in a TDMA frame. For each time slot, each cluster member transmits its measurement to the cluster head, and finally, our cluster head transmits these measurements by putting it into a single packet to the remote base station in the associated time slot. So in cluster change decision, this part is a novel and most critical part of Lefka protocol. Here, for each round, we should check that our cluster head existing cluster head will continue as a cluster head or will be changed from the other ally members. We may make this decision by using threshold value. And the determination of threshold value is also important part of LEFCA protocol. I will also explain in details. But our cluster head, then, for example, if its remaining or residual energy reaches to the threshold value, then for the next round, it should select new member from ally members. This selection is done randomly in original LEFCA, but also maximum energy selection approach and the nearest node selection approaches are applied and tried in LEFCA protocol. And also we have published these ideas in top IEEE conferences such as Black Sea Com. So here, for example, the random selection provided us lower computational complexity and lower network load, network traffic. But maximum energy selection and also nearest node selection approaches provided us also additional energy savings. But in original LEFCA, we use random selection. So to determine the threshold value and also to provide the abusement of the cluster heads, we need to analyze and derive this equation. This equation shows us the energy consumption of a cluster head while transmitting packet to the remote base station. And here, this term is very important, critical. This term shows the distance to the base station in meters. So we have a base station which is placed at the outside of the wireless sensor network. And as you see here, the fourth power, we have fourth power. And this term becomes fourth power when this distance becomes higher than crossover distance in wireless propagation channel. And these calculations and derivations are coming from the wireless propagation channel model, free space model, Nakagami fading model, as you know. So here, we should analyze according to the crossover distance. And in our calculations and in our analysis, as you remember, we use a field which has the dimensions of 100 meter to 100 meter. And for other specific parameters, we have calculated that this critical crossover distance is 87 meters. So if the distance of a cluster head is higher than 87 meters, then it will consume its energy according to the fourth power of this distance. If it is lower than 87 meters, then it will consume its energy according to the second power of this distance. So here, for all protocols in literature in wireless sensor network, they are trying to decrease this distance, this crossover distance, and they are trying to be lower than the crossover distance. So to decrease this distance, they are using especially clustering approaches, because when you use clustering approach, you significantly decrease the transmission distances to the base station. So by using this equation and by considering the worst case, what is the worst case? Here, for example, we have a sensor field which has 100 meter to 100 meter dimensions, and there are 100 sensor nodes which were distributed randomly, deployed randomly, and Here, we have an outside base station. And we think that there is only one cluster head. For example, it is located in the origin. This is the worst case. And 99 sensor nodes are node nodes. And each node has 2 joule initial energy. For this case, how much energy will our worst case cluster head consume? We need to calculate this value in joules. So when we make the calculations and derivations, we approximately obtain that this value is 0.005 joules. And to provide abusement to use the cluster head as much as possible, we decided to use the threshold value for Lefka network 10 times higher than this value, and we approximately determined it as 0.05 joules in Lefka network. But this abusement provided us additional significant energy savings and also significant throughput gain. I will show in the simulation results. But this value can be dynamic. There is no problem. For different applications, you can use different threshold values for Lefka. And if you don't use threshold value, it will behave like Leach F at the beginning, as you remember, the fixed cluster version of Leach. So it can be changed. There is no problem. For different applications, maybe there is no need to use threshold value. And also, we cannot use lower threshold value because it can cause to critical problems. For example, it can cause to network disconnectivity, and then we cannot collect any information from the network for a while. So especially think about that you are making fire measurements, earthquake measurements, or healthcare measurements. It can cause serious health problems, life problems. So for Lefka network, you should be careful in abusement of the energy of the cluster heads. And let me introduce you multi-op Lefka in one slide. Here we can talk from this figure. Sorry. For original Lefka, here let's consider first the Lefka protocol. As we know, our nodes make measurements from the environment and then transmit these measurements to the associated cluster heads. For example, here for cluster 1, it is 5th number, not 5th. For cluster 3, it is 50. For cluster 4, it is 20. And then these cluster heads make these measurements in a single packet and then transmit these single packets to the remote base station. For example, node 5 will transmit to the base station, node 11 will transmit. In multi-op Lefka, all procedures, cluster formations, cluster head selections, and all parts are same with Lefka. But here, in multi-op Lefka, node 5 does not transmit the packet to the base station individually. It transmits to the neighbor cluster head, nearest neighbor cluster head, for example, node 11. And also here, node 11 does not transmit the information to the base station directly. It transmits the collected information of cluster 1 and 2 to the node 20. And here also node 15 transmits the information of cluster 3 to the node 20. And here node 20 is responsible to transmit whole information to the remote base station. So here, node 20 has a critical role. So we should be very careful while studying here and also while using multi-op Lefka, especially for critical applications, because if any problem occurs in cluster 4 or node 20, we will lose whole information about the network. For example, you are making healthcare measurements from the body of a person, and what will we do? So here also we have some open research problems, and for researchers, PhD students, postdoc researchers, Master of Science students, we are open to collaborations about this part. How can we solve the problem of node 20 here, especially nearest cluster to the base station, and how can we provide full network connectivity, or what will we do if any disconnectivity problem occurs, any physical problem occurs? What are the solutions for these problems? This is also an open research question and field for us. And let us see the simulation results. At the beginning, we said that Lefka protocol uses an intelligent cluster at selection, but also mostly the protocols uses random cluster at selection in their algorithms, I guess. When we use intelligent cluster head selection, approximately we said that we have obtained here, as you see, 10% additional energy savings. So we have decided to use intelligent cluster selection at the beginning of Lefka protocol. And this figure shows the impact of threshold value in network lifetime. As you see, for different threshold values, you obtain different lifetime results. And here we measure the lifetime by using the number of rounds, number of information transmission to the base station. For example, what is round for us? In a round, our sensors measure the environment and then transmit these measurements to the associated cluster heads. Our cluster heads transmit the packets to the base station. So one round is completed. And for the second round, same procedures are done again and again. So as you see, approximately our Lefka protocol works 5,000 rounds. So you can measure the environment for 5,000 times, as you see from the figure. And also this figure shows the energy map of the network. For around 3,500, in Leach network, almost all nodes are dead. But in Lefka network, as you see, we have alive members, alive cluster heads, and we can collect information all parts of the networks. So Lefka protocol provides full network connectivity when it is compared with Leach and Leach-based protocols. And as you remember, at the beginning, we said that for some rounds, due to the probabilistic cluster head selection and cluster formation nature of Leach, there are no cluster formations, no cluster heads. You cannot collect any information from the network. So for critical applications, Leach is not a good candidate, but Lefka is very suitable candidate for critical applications because you can monitor all parts of the network. all regions of the environment. For example, consider you are making fire measurements in a forest and you can collect information from all parts of the field and network. And this figure shows the residual remaining energy of the LEFCA protocol and other protocols. As you see, it has approximately a robust nature and it has a non-linear distribution, but it is easy to monitor and track the energy variation of the LEFCA network, and it provides best performance when it is compared with other protocols. And also this figure shows the number of alive nodes. And in here, that node means the node becomes out of battery. There is no energy. So it cannot measure and it cannot communicate with cluster heads or other nodes. So here, as you see, the number of alive nodes results of LEFCA protocol, it provides the best performance again, and it approximately have a linear nature. So it is easy to follow the number of alive nodes, and it is easy to monitor the nodes which are alive or dead. And this table shows the lifetime results of LEFCA and other protocols. As you see here, we have average lifetime results. And here, this average lifetime results were obtained by using independent iterations. In each iteration, the network was generated randomly, and for same network, we conducted LEFCA and other protocols, and we collect the lifetime results. And for 100 independent iterations, we obtained the average lifetime results. And as you see, LEFCA has again the best lifetime performance. And this figure shows the total data transmitted to the base station. Especially here, there are some variations, but here, as you see, LEFCA has a robust nature and it always transmits packet to the base station regularly. There is no problem. And it has a cumulative nature. For example, we have started with 10 cluster heads at the beginning. And then, for example, for the round 1000, the remote cluster, all nodes in the remote cluster are dead. So it will continue with 9 alive clusters. So it goes on like that, but it has a robust and cumulative exponential nature. So it has provided additional total data transmitted results to the base station. And for different number of nodes also we have some evaluations. And in addition, we simulated the environment. What will happen when we put the base station into the sensor field? As expected, the lifetimes of all protocols were increased. And these are the comparisons of LEFCA with multi-op LEFCA. Approximately, we can say that multi-op LEFCA provides 10% additional energy savings when it is compared with LEFCA protocol. So as a conclusion, today we have talked about two novel routing protocols for wireless sensor networks. One of them is LEFCA, which has fixed clustering nature. It has threshold-based cluster selection, and it uses intelligent cluster heads at the beginning, and it aims to abuse the energies of the cluster heads to provide additional energy savings and to improve the throughput performance of existing protocols. Multi-op LEFCA is a combination of clustering and multi-op routing. It is an extension to LEFCA protocol, and it provides additional energy savings when it is compared with LEFCA and other protocols by using the neighbor cluster heads as lane nodes or gateway nodes, and multi-op LEFCA protocol was published in IEEE Access journal. So for future ideas, maybe some software-defined networking solutions can be applied to LEFCA protocol. In addition, how can we solve the energy or disconnectivity problem of multi-op LEFCA protocol, the clusters which are nearest to the base station problem also? It's another research solution. In addition, at the beginning, LEFCA and multi-op LEFCA use intelligent cluster head selection. In intelligent cluster head selection part, can we use machine learning or deep learning solutions? Can they be applied? And can it provide additional energy savings? It's another research question. And for different field dimensions, different node densities, how can our LEFCA behave? This is another research question. And finally, what can we do for LEFCA to use it in mobile networks? Because LEFCA was designed for fixed networks because it has fixed clustering approach idea. How can we apply LEFCA to mobile environments? This is also another research question. Thank you for listening. If any questions, we can discuss. Any questions?
Yeah, I call you back. Yeah, we can have questions now.
Okay. Let me see. Is there any questions? Echo, is it okay now?
There is a question in chat.
Yes, Professor, there's a question. Can you please explain about the energy efficiency while selecting cluster head?
By selecting cluster head, okay. Actually, random selection does not cause energy consumption because you are making the selection randomly. But in, for example, maximum energy selection algorithm for LEFCA, the conference proceeding in Black Sea Com, you need to collect the energy values of each node for each round to determine the node which has the maximum energy to become a cluster head for the next round. So maximum energy selection or nearest fixed clustering approaches, which are additional results obtained from LEFCA protocol and also extensions to LEFCA, cause to additional energy consumption. But original LEFCA does not consume so much energy for cluster selection process. Okay. Any more question?
Any more question?
Also, they can type to the chat box. There is no problem. I'm following it. You are welcome.
Also, Professor, can you explain what are the research areas, contemporary issues, which nowadays researchers are working on?
Research areas.
Yeah, I mean, research problems we can discuss. What kind of research challenges are there for researchers?
Research challenges. It's a good question, especially for wireless sensor network. The first research challenge is there are so many approaches, there are so many researchers study in this field. So it is hard to generate or find new solution, new idea, because there are a lot of publications. But especially specific applications, and especially trying to extend the most known protocols by using novel ideas can provide new publications and new research opportunities. For example, a PhD student can learn LEFCA truly and then can try to improve LEFCA. And it's also some problems which we mentioned here. And this can be a good PhD thesis, and this can generate some new publications, especially in SCI journals, good conferences. So I think in wireless sensor network, if you want to study and if you want to have publications and if you want to make research, you should focus on especially specific protocols or specific problems, because wireless sensor network is very wide area. It has so many applications in different fields of the research. But also nowadays, some software-defined networking or especially Internet of Things-based solutions can be applied to LEFCA protocol. You can make some combinations with Internet of Things and LEFCA. So these ideas can generate new research problems and also research opportunities. And here also there is one question. Does LEFCA give contribution to 5G network? It may give, but first you need to make LEFCA suitable for mobile applications, because as we said before, LEFCA is suitable and designed for fixed cluster applications. So as you see that in 5G networks, the nodes users are mobile. So how can we apply LEFCA to a mobile network? This is a good and big question. And also this question and this idea can generate a good PhD thesis. Mobile LEFCA is a new and promising research idea and question. Okay. Any more question?
Also, know that we have our master level students, those who are working, but they are studying IT management course, right? Information technology management.
Okay.
So from a different point of view, leave the technical part at this moment. Let us talk about the management issues. Like, what are the challenges at the time, at the time of implementation part, or when we go with some kind of critical success factors which you need to incorporate while implementing. Can you put some light on this part also?
Okay, technical challenges. Actually, for LEFCA network, we used MATLAB to conduct the simulations, to generate the environment, generate the sensor field. But especially nowadays for wireless sensor network, some specific network simulators are used. Network simulator NS2, 3, 4, and also packet tracer can be used. And nowadays, some researchers are generating the sensor fields in Python. Maybe Python can be a good candidate to generate a wireless sensor network. And in addition to them, you should have good programming skills, and also especially the wireless propagation channel part. In wireless propagation channel model, you need some additional math knowledge, because there are some additional and hard equations to solve and derive. Especially you should be familiar to exponential distributions, probability distributions, and also some wireless propagation channel models. And if you get a lecture for wireless communications, and also if you get a lecture for wireless networks or computer networks, then by using these skills and by adding some professional programming skills, you can easily study in this field. And also researchers should see the, let me type here also, oscillators, because as you know, in networking area, we study in oscillators, and for LEFCA and approximately most of the wireless sensor network protocols are working in the third layer, network layer, and sometimes also there are some combined solutions which combines data link layer with network layer. Hybrid solutions may be used. Actually, they should learn truly oscillators, and they should take 2 lectures, wireless communications and computer networks, and they should have good programming skills. Okay. Any more questions?
Yeah, thank you, Professor. Any more questions?
You are always
Sandeep
welcome,
is having
Professor.
some questions. Jadbi sir, can we allow Sandeep to speak?
What? I couldn't understand.
No, I'm talking to Jasbi sir. Jasbi sir, are you there?
Yes, sir.
Yeah, can we allow Sandeep Adhikari to speak?
Okay, just a minute.
Sandeep, just wait on.
Sandeep Adhikari is not here. I think he's gone. Yes,
He has raised the hand.
Yeah, yeah.
Excuse me, sir. Am I audible?
Yes, Sandeep. Please speak up.
Sir, is 5G network is harmful for our health or not? Is that frequency created by which is created by the 5G network? Is it harmful for our health? Most of the people are raising this question in the world.
Can you say again, please? I couldn't understand the question.
Is 5G network is harmful for our health?
Okay.
5G network connection.
He's saying, is 5G network harmful for our health?
Ah, okay. Actually, there are some discussions about that, but it is not affect the health, because its frequency is very higher. As you know, approximately 5G networks will be in higher than the 30 gigahertz. So it will not cause any problems to health. There is no any proof or verified research about that. It's a bullshit, I think. Any more question?
Okay, thank you, sir.
You are welcome. You are always welcome.
Yeah, any questions?
Let me type my email address also. Some researchers can contact me via email. Okay, they can easily contact with me for research opportunities, collaborations, postdoc, PhD, or another things. We can easily collaborate for new projects. And also we are open for new ideas, the problems of LEFCA.
Yes.
Any more questions?
So as a concluding remark, what we can say that wireless sensor network and their usefulness, specifically in this COVID time, we have witnessed that social distancing and mask and avoiding direct touch. I personally believe that wireless sensor network are the things which we should talk more about nowadays, because this is the only technology which can allow us to maintain social distancing in a proper form. And whenever we talk about smart healthcare and smart hospitals, time has come that the research community, the academic community should come together, have some new ideas, and so that we get some kind of remedies from this pandemic time. So at the last, I would like to congratulate the attendees and special thank you to the professor from Turkey for joining us. Thank you very much for joining and guiding our students. We had a very wonderful session. Very much once again.
Welcome. Thank you for your kind invitation, and
Our
it
pleasure.
was pleasure to meet you here.
Yes.
Okay, thank you so much. In addition, finally, I want to say that you are right. Nowadays, wireless sensor networks and also wireless sensor network-based solutions can be applied new areas. And for 2 years ago, wireless sensor network becomes unpopular. But nowadays becomes again popular due to pandemic. So for healthcare applications, patient monitoring, remote monitoring also, and also tracking the vaccine distribution, tracking the especially illness of the patients, their progress of patients. Wireless sensor networks can be applied and used easily. So researchers can generate new and promising solutions nowadays, especially for pandemic situation. So again, wireless sensor networks become opportunity to researchers. Again, thank you for your kind invitation. It was a pleasure to me, and let's hope to meet you
all ours. Thank you.
In future again.
Definitely. Yeah, you will be our regular panelist now.
Excuse me, sir.
Yeah, Sandeep.
Is wireless sensor network can run in underwater or not? Underwater network.
Underwater.
Yes.
Wireless sensor networks can be applied underwater networks, and also there are a lot of studies about underwater communication, especially some 5 or 6 years ago, Professor Ian Akyıldız were working about the underwater sensor networks. You can find some publications of that professor from the field. He is the top researcher in wireless sensor network. So we can apply wireless sensor network solutions and protocols for underwater sensor networks also. It is possible. But as you see that, you need to have some additional mathematical skills, because in underwater also you should have some skills about optical communications and especially optical mathematics. But by combining optical communications and wireless sensor networks, good ideas can be generated and produced for underwater sensor networks field also.
Yeah, I agree. True. Any more?
Yes, sir.
Okay, I have typed my email.
Yes, Professor, we have
to
received.
the chat box. Okay. Okay, then.
So, yeah, let us wind this session now. And once again, thank you very much. We are really obliged that you accepted our invitation, and we will stay in touch with each other, and for further sessions, more sessions will be organized.
Always.
Yeah, thank you. Thank you. Thank you, all the attendees. Thank you very much.
You are always welcome. Thanks again for your kind invitation, and hope to meet you in future events. Have a nice evening. Have a nice day.
Thank you.
See you later.
Thank you, everyone.
You are welcome. Bye-bye.